Okay. The point-slope form of a straight line is just what you would get if you did the fundamental triangle for the points x1, y1, and xy, just like we just did, except now x1, y1 aren't specific numbers, they're symbols that we can apply generally to any situation where we know a point and a slope. Well, that fundamental triangle is going to tell us that the slope, which we call m, is equal to the slope of that triangle, which is this. And I think we understand this quite well. Then if we multiply through by this denominator, we get this. That pretty much goes without explanation, except make sure we got the parentheses around that x minus x1. And this is what we call the most standard point slope form. It's totally equivalent to this form. You could use either. If you use this one, you don't have to do any multiplication by a denominator. If you use this one, though, you can always multiply by the denominator. And of course, you can always go back and draw your fundamental triangle. Okay? It's all equivalent. You get the same result with any of these forms. So now, if we want to line through the point 2, -6 with a slope -3 as on problem 2.1 cell 5 on this document, then our point is x1, y1, that's 2, -6, so that x1 is 2, y1 is -6, and the slope is -3, so m is -3, and we get then y minus y1, y1 is -6, y minus -6 equals m, which is the slope -3, times x minus x1, that's x minus, let's see, x1 is 2. Whew. First time I've ever managed to damage the thing there. We go. Okay. And then we solve for y. You get -3x, -3 times -2 is 6. We have a plus 6 over here. We're going to subtract 6, and actually, I believe that turns out to be it. Okay? Now these points are randomly generated. Didn't intend to give you something that simple. Usually you'll have plus or minus some number. But there it is. Okay? Now the other equation is line through -7, 2, and 9, -5. Okay? So, one of the points will be x1, y1, doesn't matter which, but we'll take the first one. x2, y2 equals 9, -5. And all we need to get the equation is an x1, a y1, an x2, and a y2, right? Everything else is just plain old x and y, and of course our equation is going to have just an x and a y in it. So we get y minus y1, well, let's see, y1 is 2, okay? And that equals y2 minus y1 over x2 minus x1 times the x minus x1. Well, y2 is -5, y1 is 2, so it's -5 minus 2. And x2 is 9, x1 is 2, so we get 9 minus 2. And that's multiplied by x minus, now we have to have an x1, remember that is -7. Okay? And we can solve this for y. And we have time, we might as well go ahead and do it. Y minus 2 equals then -7 over 7. Conveniently, that's going to be -1. We'll get that in the next step. Times x plus 7. That's very easy to complete this. And we're going to end up with y equals x plus 9. Now let's just make sure that this is right. And actually, it isn't.
Live form, isn't it? Because -7, that's -1.
That's -1. And I lost my negative glad somebody's paying attention. Okay, it's negative x, and that's going to be negative 7 plus 2, and it's going to be negative x minus 5. And that's good because it wasn't going to work the way it was before. Okay? Okay. That's still not right.
It's negative 7, so that'd be negative 9.
If we put 9 in here, we get negative 9 minus 5. That's negative 14. It's not negative 5. So, you know, I'm being completely ignorant. Tell me what I'm doing wrong.
You said negative 14.
Y minus 2 equals.
Well, okay, let's do the intermediate steps that I'm skipping. Okay? Let's see if there's something wrong here. Y minus 2 equals negative x minus 7. Okay? And we add 2 to both sides. And we get y equals negative x minus 5, which is what I wrote down here. But it's not right. At this stage, I would draw the fundamental triangles and confirm that I did it right. I'd look at my formula and check it, and yeah, the formula's right. So I'm not sure what's wrong there, so find out what I did wrong and fix it, okay? Should have worked. If we come up here, y equals negative 3x. If x is 2, we get negative 3 times 2, which is negative 6. It confirms this point, right? Let's see if this confirms the other point. If x is negative 7, then we get 7 minus 5, which is 2. So this point works. But this point doesn't appear to work, which means I've got something wrong involving the 9 and the negative 5. But let's see. That's x2, it's 9, and y2, uh-oh. No, sorry. I still don't find an error, but there is one. Okay? Now, we understand that this equation checks out with the given point, right? And has the right slope. This equation, for some reason, checks out with the first point. If we put in x equals negative 7, we do get y equals 2, but if we put in x equals 9, we get negative 14, which doesn't match the negative 5.
Should that be negative 7 over 9 and not negative 7 over 7?
No, 9 minus 2 is 7.
Oh.
Okay? I mean, it's good. I'm glad you're looking at it, but I still don't see what's wrong. Okay, so we'll close the class because it's just about time to close on that error. See if you can fix it for us.